Okay, now let's try to look at how we can calculate for the mole of a given element. How do you calculate the number of moles for a given element? Okay, so whenever you've been asked to say calculate the number of moles for blah 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 blah, it becomes very simple for you to easily understand what they're talking about. It becomes very simple for you to easily understand what they're talking about. By the way, if you want to calculate the number of moles, you say number of moles must be equal to the mass of that same element given in the question. You divide it by the molar mass. Where do you get this molar mass? The molar mass is found on the periodic table. All the masses or all the numbers that are in a form of decimal places, do not consider those numbers that are smaller, like 1.2. Those are what we call electronegativities, like we said in the previous lesson we had for molecular geometry and also Lewis structure. So here, this has to be the formula that we should always be using whenever you want to calculate for the number of moles. But how do you define the same moles? If we look at a simple definition, we are going to understand to say a mole is just a unit of measurement that is being expressed in a form of the quantity of a substance in a given element. So here I'll say mole is a unit of measurement that express the amount of a substance that contains elementary quantities. Okay, what are the SI units for moles? The SI units for number of moles are given as MOL. Mole are given as MOL. Okay, now here you find that as you're trying to find the number of moles for a given element, whether in a chemical equation or they have just asked you to say, can you calculate this number of moles based on this, based on that? Okay, here there is a simple relationship again. The number of moles is related to a certain quantity which is called particles or atoms. Particles or atoms. As we are trying to do certain things, like if you say 1 dozen, it is equivalent to what? It is equivalent to 12 units or 12 objects. Same applies to the number of moles. Same applies to the number of moles. One mole is equivalent to a certain number which is called Avogadro's constant. And Avogadro's constant is not something which is universal, like it is constant without even changing. It depends on the quantities you are trying to talk about. If you are talking about the issue of particles, one mole is equal to a certain number that I'm going to display here. Again, if you're talking about atoms, it becomes the same thing. I'm saying one mole is going to be equal to a certain number which is not a constant number. They're saying it is a number which is said to be Avogadro's constant, but it keeps on changing depending on what you're dealing with in that specific question. And this number looks like this: 6.022 multiplied by 10 to the power 23. So this number, it can either be particles, it can also be atoms, and also it can also be what? Molecules. So whenever a question has come like calculate how many particles are going to be found in this number of grams, in this number of moles, it becomes very simple for you to calculate. We say 1 mole must be equal to that. The number of moles you are going to find here must also be equated to what? To x, and you just cross multiply. They are going to reach on the what? On the final answer. What if it has been expressed in a form of an equation? What if it has come in a form of an equation? How do you express it? How do you express it? A good example is this. If you've been given an equation like copper carbonate, you decompose this same compound. We understand to say it is going to produce certain things like copper oxide plus carbon dioxide. So if we check this reaction, we have 1 copper, we have 1 copper, we have 1 carbon, 1 carbon, we have 1 plus 2 oxygen, we have that one also, meaning that this equation is already balanced. So we are going to understand to say we are going to have 1 more for this, 1 more for that, and 1 more for this. How do you find the same number of moles based on these same things? You look at what coefficients you've been given. This reaction is already balanced. Why? Because we have the same number of quantities on the left hand side with those that are found on your right hand side. Okay, so here what I would like to say, I'm going to say 1 more for copper carbonate is equal to how many particles or how many atoms? We are going to have 6.022 multiplied by 10 to the power 23 atoms. You can even put molecules, whichever. Same applies to this. You can also relate to say 1 more of copper oxide is going to be equated to the same number which is here. Okay, it is going to be equated to the same number which is there. Alright, so that's how whenever they ask you to say, can you calculate the number of particles? They mean you need first of all to convert, if you've been given the masses or the mass of a given element, you have to convert that same number of mass into the number of moles. And now we are going to relate to say 1 mole is going to be equal to that. The number of moles you are from finding, you are going to equate them to what? To x. You are going to equate them to x. Okay, let's look at an example. We try to look at an example so that we can proceed. Okay, our example goes like this. So I'll say how many moles of sulfur how many moles of sulfur are there in 0.987 grams of sulfur. This question is straightforward. We need to calculate for the number of moles of sulfur. Remember the formula I'm from giving you. The formula of calculating for moles, you need first of all to know what is the molar mass for what, for a given element that we've been asked. In this case, we're trying to talk about sulfur. We understand that the mass that has been given is this one, but they want us to calculate the number of moles. Out of this, what are we going to get for for sulfur out of this one? Okay, so first of all, you need to analyze the data. You say data. What information have you been given? Number of moles, we don't know. Mass, you've been given the mass as what? 0.987 grams. Okay, now you come to molar mass. Molar mass, if you go on the periodic table, I think for sulfur we have a certain number of a molar mass, which is 30.07 if I'm not mistaken, and this one must have units like grams per mole.
It is 32.065.
Okay, sorry, it has to be 32.06 or 07, right? Okay, let me put it like 0. Let me write it as 32.06 grams per mole. To calculate the number of moles, we are going to use the same formula. I'll say N, it has to be equal to mass over molar mass. So here we are going to say what is the mass that we've been given in the question. The mass given in the question is 0.987. I will divide this by 32.06. Okay, so the calculator is very allowed for you to use it. 0.987 divided by 32.06. So we are getting the total number of moles for sulfur, or rather out of 0.987 for sulfur as what? 0.0308 moles. So this becomes the total number of moles that we can get out of that given mass. If they ask you to say how many atoms are going to be in this same number of this same amount of sulfur, it becomes very simple. Do not equate this direct to your or do not punch this in your calculation. You need to convert first of all this to what? To number of moles. Meaning that for you to find a given number of molecules out of this, what you are going to do now, you say 1 mole is equal to 6.022 multiplied by 10 to the power 23. I'll say molecules, atoms, whichever. Then you write this number where there is number of moles again. I'll say 0.0308. You are going to equate it direct to what? To x. You multiply this multiplied by that, we are going to have x. I'll say equal to. If you try to multiply here this and that, it will give you an answer here which is going to be like this. And how do you punch this number? To punch this number, just say 6.022. You look at this number or this letter which is given here, this symbol which is given here, exp. It simply means exponential. If you punch here, you just straight write the number which is found on the top part here. This one, if you write it or you want to punch this number, this symbol, it is already expressed in a form of times 10 to the power. So you just write 23 somewhere there, and then you are going to say, I'll say equal to, and it has been displayed like what I'm from saying here. So you are going to write it in the form of, you say multiply by 0.0308. So I'll say equal to, and this becomes the total number of atoms or molecules or particles that we can have out of that given number of mass. So here we are going to have 1.85 times 10 to the power 22. And you need to put the units based on what you are going to be asked. If it's atoms, you are going to write atoms again, looking at what we've been given somewhere there. So we are going to have atoms just like this. Okay, just like that. So the number has to be 1.85 times 10 to the power 22 atoms, or if it's particles, you are going to replace with particles. If it's molecules, you are going to put molecules.